The last side works with the coordinate points. So we have to tell whether this is a rhombus, a rectangle, or a square using coordinate points. Distance formula is the difference of the x's squared plus the difference of the y's squared. Slope formula, again, is y2 minus y1 over x2 minus x1. If I'm trying to prove this is a rectangle, the two things I need to do, I can either use slope or I can use distance. If I want to use just slope for my formula, I would be proving opposite sides are parallel and consecutive sides are perpendicular. Since this is a rectangle, really all I have to do is just prove that consecutive sides are perpendicular. Since it's already a parallelogram, we know that. Since it's if I wanted to use just distance, since it's already a parallelogram, I don't have to prove the opposite sides are congruent. I just have to check that the diagonals are congruent to each other. So I could use one or the other. You don't have to do both. If I want to prove this is a rhombus, if I want to do this with just with slope, so I could use the slope method. I need to prove the opposite sides are parallel. But again, we know that because it's a parallelogram. They told us that. So I need to prove that the diagonals are perpendicular. Or, if I want to use distance, I need to prove the opposite sides are congruent. Well, I know opposite sides are congruent, so with distance, all I'm proving is that all sides are congruent. And that's it. If I want to prove this is a square, if I want to use slope, then I have to prove the opposite sides are parallel, which we know already it's a parallelogram. We need to know that consecutive sides are congruent, and we need to know, hold on, we're doing just the slope formula. I need to know that consecutive sides are perpendicular, and I need to know that the diagonals are perpendicular. So you can prove that sides are consecutive, but you need to do one more, because all this does is prove that it's a rectangle. So the one more I would do is diagonal if we're just doing slope, or you could check that the diagonals were congruent. Okay, option number 2, if you're just doing distance, all opposite sides congruent, but we already know that because it's a parallelogram. They gave us that. And then we would prove that the diagonals are congruent. So here's the thing with this one. If you just, there are other combinations you can do with this, but just remember that it's either, if it's a parallelogram, it's either a rectangle or it's a rhombus. And then you have to prove something that it's a square. So let's work through this one. We have these sides of this shape. So I'm going to say, I know that this one is correct with the order that it's written there, so I'm going to just draw my shape. I don't know what it really looks like. So this is A is at -2, -1. B is at -1, 3. C is at 3, 2. And D is at 2, negative 2. So first thing, let's prove if this is a rectangle or not. We're just going to use the slope on this one. So I'm going to find the slope of AD, the slope of AB, the slope of BC, and the slope of CD. So I've calculated the slope of each of these, and when I come up with the slope, I see that MAB is, the slope of AB is 4, the slope of the one next to it is negative 1/4. Slopes with the opposite reciprocals are perpendicular. So I know at least that this is a rectangle. But then I have to check to see if this is a square. So to see if this is a square, it should have the traits of a rhombus for the sides, and then the diagonals could be perpendicular. So from here, I could either say, okay, I want to figure out that the sides are all congruent, all sides, or I could figure out that the diagonals are congruent, or I could figure out that the diagonals are perpendicular, which is a trait of a rhombus. So I'm going to use all slope on this one. So I want to figure out if the diagonals are perpendicular. So this one, I wanted to figure out if consecutive sides perpendicular. And I could have done any one of these. It would have been fine. If I wanted to figure out all sides were congruent, just use the distance formula. Same thing with this one. But this one, you'd want to use slope. So I'm going to figure out the slope of diagonal DB. And then I'm going to figure out the slope of AC. Okay, so I figured this out. The slopes are negative reciprocals. So the diagonals are perpendicular. And the consecutive sides are perpendicular. So therefore, this is a square. If the diagonals were not perpendicular, then I would stop at rectangle, because this would have been all that we could prove. Diagonals being perpendicular would have proved rhombus or square. Okay, I want you to try this one and see what you can come up with. This one, I'm going to do a distance formula, but you can try it either way. So I worked through the distance formula with each of these sides. DE, I got a length of 5. EF, I got a length of 5. GF, I got a length of 5. DG, I got a length of 5. So I know that this is at least a rhombus or a square. So we're going to get more specific, because the idea is to figure out which specific one it is. So we're going to go and figure out another step with this. If I want to use distance formula, the thing that makes a square different from a rhombus is the diagonals are congruent. Because in a rhombus they aren't congruent, so we're going to go and try that. So I'm going to find the distance DF. And EG, that's the last step of this. So I use the distance formula on this, and the formulas, double check them, triple check them, we still get different diagonals. So if the diagonals are different, this is not a square, but it is a rhombus because all the sides are congruent. Okay, this is the Zener. So, go forth, do your homework. You're awesome.